right, today we are starting chapter 7, and what we're going to do here on this page is we've got 3 theorems to talk about. So what we're going to do is talk about a theorem, do the example that corresponds with it, talk about a theorem, do the example, and kind of bounce back and forth so you can hear about it and then see what it actually looks like when you're doing the math. So the first one, theorem 50, you should be very familiar with at this point. The sum of the measures of the 3 angles in a triangle is always going to be 180. You've been doing this since the beginning of the school year, so maybe just to think about it in a little more challenging sort of way, if I have this diagram with 2 overlapping triangles, how would I find x, y, and z? Now, if you're one of those people that likes to find x first, you are going to be disappointed here because you have to find x last, unfortunately. So I'm going to look for y first. Now, y is one of the angles in this triangle on the left. So if you need to kind of visualize just one triangle, this triangle has 3 angles, 55, 80, and y. So to find y, I'm going to subtract those 2 angles I know, 80 and 55, from my total of 180, and that is going to leave me with 45. So angle y is 45. Now I'm going to look at z, which is part of this other triangle on the right. And to find z, I'm going to do something similar and subtract 180 from these 2 angles that I know, 160, and that will leave me with 20. So then last but not least, to find x, I'm going to look at this tiny triangle in the middle, and my 3 angles are x, y, and z. Well, I know y and z are 45 and 20, so to get x, I'm going to take those away from 180. And that gives me 115. So my x, y, and z values as an ordered triple, 115, 45, 20. So that is your theorem 50. Now theorem 51 is an exterior angle theorem, and this says that the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So remember, exterior means outside of your triangle. Your interior angles are obviously inside, but the remote interior means they are not touching your exterior angle. So when your exterior angle is here, your remote ones are the 2 that do not touch that exterior angle. So moving on to example 2 here on the practice problems, we want to find x and y, which tells me that this is going to be a system. So I'm going to need 2 equations. So looking in this diagram, my exterior angle is 125. Well, I know now from theorem 51 that's going to be equal to the sum of my 2 remote interior. These are my 2 remote interior because they're not touching the 125. So that's a right angle, which I know is 90, and x plus 2y. So those 2 together are going to add up to 125. There's one of my equations. For my second equation, I have a few options. I can say that these 3 angles in my triangle add to 180, or that these 2 angles add to 180 because they're forming a straight line. I'm just going to go with these 2 angles that form the straight line because it's less things that I need to write down to make it happen. So there are my 2 equations. I'm going to clean them up a little bit. On this top one, I'm going to move the 90 over so that I'm just dealing with variables on one side and constants on the other. Same thing for my second equation. I'm going to move the 125. Now I've got 2 equations. You can do substitution or elimination. I'm going to do elimination and eliminate my x's by multiplying the top equation by -2. So that'll give me -2x minus 4y equals -70. Then -3y equals -15, which means y is 5. Then to find x, you can plug this into any of these equations. I'm going to go with that top one. X plus 2 times 5 is going to give me 35. So if x plus 10 is 35, that means x is 25. So my solution here, ordered pair, 25 and 5. Okay, theorem 52, last but not least, your midline or mid-segment theorem. This refers to if you have a triangle and you draw a segment through your triangle connecting the midpoints of the 2 sides it crosses. Remember, midpoint means it splits it in half. So if D is a midpoint, DA and CD would be congruent. And if E is a midpoint, CE and EB would be congruent. So if this segment connects those two midpoints, I can call it a midline or a mid-segment. And then by definition, I know it's going to be parallel to that third side of my triangle, and it's also going to be half its length. So both of those characteristics are important to help me find missing values, like in example 3. So here I have this triangle. These tick marks here being congruent tells me that this is a midpoint. These tick marks here being congruent tell me that this is a midpoint. So I know I have a midline or a mid-segment. So these two are going to be parallel, and this inside segment is going to be half the length of my outside segment. So let's find C, D, and E. I'm going to start with C. Remember, this 32 is half of CD, or of C. So C is going to be twice that, which is 64. D is referring to this angle here, which if you need to kind of extend these parallel lines to visualize it better, what I have are parallel lines crossed by a transversal. So the 65 and the D are corresponding angles, making them congruent. So this is also going to be 65. And then lastly, to find E, I do have this outer triangle with 3 angles, 2 of them being 65 and 43. If I subtract those from 180, what that leaves me with left over is 72. So that concludes those 3 theorems on that page. I do want to do a few more practice problems to make you prepared for your homework and eventually for a test. So we're going to do a few more examples here on the back side. So starting with example A. The measure of the 3 angles of a triangle are in the ratio 3 to 4 to 5. We've been doing problems just like this since the first 6 weeks. When you see a ratio like that, you know that means you're going to say 3x, 4x, and 5x. And if those are representing the interior angles of my triangle, they need to add to 180. So that means that 12x is 180, so x is 15. And now if I want to find the largest angle, that's going to be 5x. So 5 times 15 gives me 75. Okay, A should be a breeze for you. Now B is a little different, and it will show up on your homework and it will show up on a test. So pay attention to this one closely, if nothing else today. One angle of a triangle is 80 degrees. That's already labeled in my picture here at A. Find the measure of the angle formed by the bisectors of the other 2 angles. So what that has done here, I've bisected angle B, that's why these are both X, and I bisected angle C, that's why these are both Y. What this has done is formed a smaller triangle on the inside, and I'm going to use that as well as the outer large triangle to help me solve this. So starting with the outer triangle, I've got these 3 angles that have to add to 180. So that's going to be 80 plus these 2 together give me 2x, and these 2 together give me 2y. Those 3 have to add to 180. Now I'm going to take this equation and do a little bit of algebra magic to it. I'm going to subtract 80 on both sides. So 2x plus 2y equals 100. Now I know everything in this equation is divisible by 2, so I'm going to do that. And that will leave me with x plus y being equal to 50. Okay, I'm going to store this aside for a moment and come back to it. If I focus my attention to this smaller triangle on the inside, I still have 3 angles that have to add to 180. So here that would be x plus y plus whatever angle E is. Those 3 have to add to 180. Now, I don't know what x and y are individually, but I do know that x plus y is equivalent to 50. So I can substitute that 50 in here for x plus y and then solve for angle E as 130. So this one is a little different. It's a little tricky because when you see the x and y, you might initially think that this is a system, but this one just uses some magic instead of solving a system. Okay, moving on to C. Angle 1 is 150 degrees. Angle D is twice that of angle E. So what I'm going to do to represent that is let angle E be equal to x, and so that means that D would be 2x. To find the measure of each angle, well, I'm going to need to solve for x, and if I look closely, I know that this is my exterior angle, and these are my 2 remote interiors. So the sum of these two, 2x and x, needs to add to 150. So that would mean 3x is equal to 150, therefore x is 50 degrees. So I know angle D is going to be 100, angle E is going to be 50, and angle DFE will leave me with 30. And with that information, you could also answer questions about this triangle as far as which sides are the longest and which ones are the shortest. Okay, last but not least, D. D and E are midpoints of AC and CB. So if D is the midpoint, that means it's splitting the segment in half, so these two are congruent. If E is the midpoint, that means it's splitting this one in half, so these two are congruent. So what that means is DE is a midline or a mid-segment, which means these two sides will be parallel, and DE will be half the length of AB. So let's continue on with what I'm given. AB is perpendicular to CB. That means that this is going to be a right angle. Angle CDE is 40 degrees, and DE is 7 long. So I want to find these four things, and I'm just going to go in the order it asks for them. So starting with angle A. That is down here. Well, because I know I have these parallel lines, these two angles are going to be corresponding. So A will also be 40 degrees. For angle C, I've got an outer triangle here. I've got an angle that's 40, an angle that's 90, so that would leave me with 50 here for angle C. For angle CED, you have two options. You've got an upper triangle here, so you could subtract from 180 to find that missing side, or you know that these two are corresponding, so this will also be a right angle. And then lastly, AB is going to be double the length of DE, so that would be 14. And that wraps up our notes on 7.1.